Hello students, how are you all? Welcome back to Akshar IIT Foundation classes. I am your chemistry faculty. Right? So students, in the last class, we started the second chapter of volume 2, that is mole concept and stoichometry. Right? In that we discussed the synopsis 1. Right? And today let us start the synopsis 2. Today, let's start synopsis 2. So, in the synopsis 2, what we are going to learn? So, students, the very important topic we are going to learn, that is a mole. What it is? A mole. Do you know what is a mole? Yes, not English mole. This is a chemistry mole. Okay. So, mole generally in your certificates they'll write a mole on the chin, a mole on the cheek, something. That's not this mole. This is the mole, chemistry mole, right? So, mole is what? Did you learn? Did you hear this word? Yes, I think in the physics somewhere units and dimensions, right? Right. So, here mole is a SI unit of quantity of matter. So, in the chemistry, the quantity of matter is measured in terms of mole. In terms of mole. Okay. So, that is about the mole. Right. So, what is a mole? Right. So, see students, here mole is nothing but a okay. So, before going to the mole, I'll say like dozen. Okay, you know the dozen. What is the dozen? Dozen means what? 12. Dozen is equal to what? 12. Right? If you take 1 dozen of bananas, the meaning is what? You are taking the 12 bananas. If you take 1 dozen of apples, the meaning is what? You are taking 12 number of apples. So, dozen represents what? Number of apples or number of bananas, whatever you are taking, that's number, that is 12. So, dozen means what? That is 12 fixed number, right? Similarly, mole is also a fixed number. Mole is what? A fixed number. And what is the value of that number? That value, the number of is 6.023 into 10 to the power of 23. 6.023 into 10 to the power of 23. Okay. So, like 1 dozen is equal to 12. How? Similarly, 1 mole is equal to 6.23 into 10 to the power of 23. Okay. So, see here, 1 dozen of bananas means what? 12 bananas. 1 dozen of apples means what? 12 apples. Similarly, 1 mole of, so listen carefully students here, 1 mole of hydrogen atoms. Okay, 1 mole of hydrogen atoms. So, the meaning is what? 6.023 into 10 to the power of 23. This many hydrogen atoms. Clear? So, 1 mole of hydrogen atoms means what? 6.023 into 10 to the power of 23 hydrogen atoms. Okay. For example, 1 mole of hydrogen molecules. Hydrogen molecules. How do you represent the hydrogen molecules? You represent in the form of H2. Hydrogen molecule is what? H2. So, 1 mole of hydrogen molecules. Okay. So, the meaning is what? It consists of same 6.023 into 20 to the power of 23 hydrogen molecules. Okay. Hydrogen molecules, right? So, 1 mole of hydrogen atom means what? 6.023 into 10 to the power of 23 hydrogen atoms. If I say that 1 mole of hydrogen molecule means what? It consists of 6.023 into 10 to the power of 23 hydrogen molecules. Clear? So, now For example, if I ask you, how many hydrogen atoms are there in the 1 mole of hydrogen molecule? So this is 1 mole of hydrogen molecule, and 1 mole of hydrogen molecule is equal to, this consists of 6.023 into 10 to the power of 23 hydrogen molecules, H molecules. But I'm asking, 1 mole of hydrogen molecule contains, this contains how many hydrogen atoms? How many hydrogen atoms? Okay, come on, say now. Check. 1 mole of hydrogen molecule contains 6.023 into 10 to the power of 23 hydrogen molecules. Now, this 1 mole of hydrogen molecules contains how many hydrogen atoms? That I'm asking. Okay, hydrogen atoms, right? So now what do you do for this one? 1 mole of hydrogen molecule is not 2 hydrogens, right? Now I'm asking how many hydrogen atoms. So what you need to do? 1 hydrogen molecule consists of 2 hydrogen atoms. So what you have to do? 2 into, okay, 1 mole of hydrogen consists of how many? 6.023 into 10 to the power of 23 hydrogen atoms. Is this clear now? Now, if you want to multiply, so 2 3s are 6, 2 2s are 4, 2 0 0, 2 6 are 12. So 12.6046 into 10 to the power of 23 hydrogen atoms. Clear? Or you just, if you bring the point here, 1.2046 into 10 to the power of 24 hydrogen atoms. So this is about the 1 mole of hydrogen atoms, the number of hydrogen atoms in 1 mole of hydrogen molecule. Is this clear? One second expense here. The mole is nothing but a 6.023 into 10 to the power of 23. That's a fixed number. Okay. If I say that 1 mole of hydrogen atoms means what? This 1 mole of hydrogen atom consists of 6.023 into 10 to the power of 23 hydrogen atoms. If I say that 1 mole of hydrogen molecules means what? It contains 6.023 into 10 to the power of 23 hydrogen molecule. But each hydrogen consists of how many hydrogen atoms? Each hydrogen molecule consists of 2 hydrogen atoms. So, if 1 mole of hydrogen molecule consists of 6.023 into 10 to the power of 23 hydrogen molecules, how many hydrogen atoms are present in 1 mole of hydrogen molecule means what? So, each molecule consists of 2 hydrogen atoms, like this 1 mole. So, 6.023 this one. So, this is about this one. Once you check correct only, yeah? Okay, so did you understand now? So, that is 1 mole. Okay, so 1 mole is nothing but a 6.023 into 10 to the power of 23 entities. Means if you are taking 1 mole of atoms, then that is 6.023 into 10 to the power of 23 atoms. If you are taking molecules, so 6.023 into 10 to the power of 23 molecules. So what you are taking, if I take 1 mole of pens, the meaning is what? 6.023 into 10 to the power of 23 pens. So this is a number of moles. Clear to you? Okay. Now, for example, sometimes you may ask like this. Okay. So 1 mole of water consists of how many molecules? Okay. So just now I told you that 1 mole of water formula is what? H2O. So 1 mole of water molecules means what? It consists of 6.023 into 10 to the power of 23 molecules. Right? Now, sometimes the question may ask you that how many hydrogen atoms are there in 1 mole of water molecule, or how many oxygen atoms are there in 1 mole of water molecule. So here you know that 1 mole of water molecules consist of 6.023 into 10 to the power of 23 molecules, right? This you know. But they don't ask you like how many molecules are there. You know that 1 mole is equal to this much. Okay, but they ask you how many hydrogen atoms are there or how many oxygen atoms are there. Okay, so then what can you do? So see here now. So 1 water molecule consists of 2 hydrogen atoms, right? So 1 mole of water is equal to 6.023 into 10 to the power of 23. Now 1 mole of okay. So now the number of hydrogen atoms. Okay, in 1 mole of water. 1 mole of water. Okay, of water. So now each one molecule of water consists how many? 2 hydrogens. So write 2 into okay, 1 mole of water. So this is this number 6.023 into 10 to the power of 23 molecules, sorry, atoms, hydrogen atoms. Clear? How many oxygen atoms? One molecule consists of one oxygen only. So 1 mole of water consists of same number. So now the same you can write the number of oxygen atoms in 1 mole of water. Okay, 1 mole of water is equal to one water molecule consists of only one. So 1 into this number 6.023 into 10 to the power of 23. That's all. Okay. So like this you can calculate okay, the number of atoms or number of molecules present in the 1 mole of any substance. Is this clear to you, students? Any doubt? So here this 1 mole is nothing but this is a fixed number. What is that fixed number? 6.023 into 10 to the power of 23. This is also known as Avogadro's number. Okay, this is also known as Avogadro's. Okay, Avogadro's number. And this Avogadro's number is denoted by Na. So wherever if you see the Na symbol, the meaning is that is Avogadro's number. And Avogadro's number consists of what? Is nothing but a 6.023 into 10 to the power of 23. Clear? Any doubt? Okay. Chalo. Now the question rises. I think this already we discussed, but once again, okay, for your information. So this 1 mole concept from where it has taken. Okay. So here, students, already we discussed in the previous class the atomic weight. Okay. So 1 AMU, 1 atomic mass unit. 1 atomic mass unit, the standard one is taken as 12th part of the carbon. 12th part of the carbon. Yes. So 1 AMU, 1 atomic mass unit is equal to 1 by 12th of carbon C612. Okay. Carbon atom. Okay. Atom's mass. Okay. So the carbon atom mass is taken. That is divided into 12 parts. So that is equal to 1 AMU. This already discussed. Now, this 12 grams of carbon, okay, this 12 grams of carbon, which carbon with atomic number 6, mass number 12, contains, okay, contains how many number of atoms? See here, 12 grams of carbon, C612 contains 6.023 into 10 to the power of 23 carbon atoms. This is very important point you need to remember. Okay. So, the 12 grams of carbon contains 6.023 into 10 to the power of 23 carbon atoms. Okay. Now, for example, so here 12 grams. So, here you see, if you see the carbon, here mass number or atomic mass of the carbon is 12. So, 12 is a mass number. So, here you see 12 grams. So, 12 grams of carbon contains 6.023 into 10 to the power of 23 carbon atoms, right? Which is equal to Avogadro's number or which is equal to 1 mole, which is equal to 1 mole. Now, for example, if I take oxygen, oxygen atomic number is what? 8. Mass number is what? 16. This is the oxygen. Okay. Now, what is your mass number? 16. So, here 16 grams of oxygen contains, okay, contains 6.023 into 10 to the power of 23 oxygen atoms. Oxygen atoms. That is again equal to the Avogadro's number. Clear? So, mole is nothing but a number which is equal to 6.023 into 10 to the power of 23. Which is also equal to, which is also called Avogadro's number. And Avogadro's number represents what? The total number of atoms that present in the 12 grams of carbon. That present in the 12 grams of carbon. So, 12 grams of carbon consist of 6.023 into 10 to the power of 23 carbon atoms. Okay. Similarly, 16 grams of oxygen contains 6.023 into 10 to the power of 23 oxygen atoms. Right. Now you see based on this one, okay, carbon mass number is 12. So 12 grams of carbon consists 6.023 into 10 to the power of 23. Oxygen mass number is 16. So 16 grams of oxygen contains 6.023 into 10 to the power of 23. Right. Now, for example, if I ask you how many grams of calcium, okay, how many grams of calcium contains 6.023 into 10 to the power of 23 calcium atoms. Then how can you say? Very simple. Carbon mass number is how much? 40. Atomic number 20, mass number 40. Yes or no? Calcium, atomic number 20, mass number 40. So therefore, 40 grams of calcium contains 6.023 into 10 to the power of 23 calcium atoms. Clear now? So here if you take the mass number of any atom is equal to, means if I take for example hydrogen mass number is what? 1. So 1 gram of hydrogen if I take, that consists of 6.023 into 10 to the power of 23 hydrogen atoms. If I take helium atomic mass is how much? 4. So meaning is what? 4 grams of helium contains 6.023 into 10 to the power of 23 helium atoms. So their mass number, okay, what is there? That if you express in the grams, that many grams of that particular atom contains 6.023 into 10 to the power of 23 atoms. Clear? Okay. Now last and final, sodium atom. Okay. So sodium atom, how many grams of sodium contains 6.023 into 10 to the power of 23 sodium atoms? Very good. Sodium mass number is what? 23. So 23 grams of sodium consists of 6.023 into 10 to the power of 23. Clear? Yeah. Okay. So now we came to know that atomic weight. What is that? Atomic weight. Atomic weight of any particular element. Atomic weight of any particular element. Okay. That many grams. Okay. Atomic weight of any particular element, that many grams contains 6.023 into 10 to the power of 23 atoms. Okay. But if you take the molecule, for example, now we've taken the water molecule, right? I have taken 1 mole of water molecule, and 1 mole of water consists of how many? 6.023 into 10 to the power of 23 molecules. This just how I explained you. If I ask you 6.023 into 10 to the power of 23 water molecules, okay, equals to how much weight? Equals to how much weight? So see here, for example, here examples here, 6.023 into 10 to the power of 23 carbon atoms consist how much weight? 12 grams. 6.023 into 10 to the power of oxygen atoms weight is how much? 16 grams. 6.023 into 10 to the power of 23 calcium atoms mass is how much? 40 grams. Right? Did you understand? Now we are coming in the reverse order. Okay. So 6.023 into 10 to the power of 23 carbon atoms mass is equal to 12 grams. 6.023 into 10 to the power of 23 oxygen atoms mass is 16 grams. 6.023 into 10 to the power of 23 calcium atoms mass is 40 grams. Now similarly, if a 6.023 into 10 to the power of 23, okay, see here now, observe carefully here. 6.023 into 10 to the power of 23 molecules of water weights how much? Of water weights how much? Then it's very, very simple, students. So once again, see here, 6.023 carbon atoms is equal to 12 grams, means what? Carbon atomic weight. 6.023 23 of oxygen atoms is equal to 16 grams, oxygen atomic weight. 6.023 into 10 to the power of 23 calcium atoms is 40 grams, means calcium atomic weight. Correct? So here 6.023 into 10 to the power of 23 molecules of water weighs how much? What is its weight? So you know that what is the formula of water? H2O. So how many hydrogens are there? 2 hydrogens. Hydrogen mass is how much? 1. Plus how many oxygens are there? Only 1. Into what is the mass of oxygen? 16. So 2 ones are 2 plus 16 is equal to what? 18. What is this 8? Molecular mass of water. So how much we got? 18. So just you write 18 grams, okay, of water contains 6.023 into 10 to the power of 23 molecules of water. Clear? Okay. Now, for example, if I ask you, what is the weight in grams of 1 mole of carbon dioxide? Okay. So 1 mole of carbon dioxide, CO2. Okay. This is there. I want its mass and number of molecules. I want. You know that 1 mole is equal to how many number? 6.023. Yes. So 1 mole of carbon dioxide consists of 6.023 into 10 to the power of 23 carbon dioxide molecule. This we got it, right? So 1 mole represents this number. Now what I said, this number mass is equal to how much I said? So then what I said, I have to calculate the molecular mass of carbon dioxide. So molecular mass of carbon dioxide means how many carbons are there? 1 carbon. How many oxygens are there? 2 oxygens, right? 1 carbon plus 2 oxygens. Okay, 2 oxygens, right? So there is not 20, 2 oxygens. So carbon atomic weight is 12 and 2 into oxygen. Oxygen 16, 16 2s are 32. So 12 plus 32 is equal to 44. So 44 grams of carbon dioxide. 44 grams of carbon dioxide consists of 6.023 into 10 to the power of 23 carbon dioxide molecules. How simple. So if they ask you 1 mole of hydrogen mass, so okay, 1 mole of carbon mass, so it's nothing but its mass number 12. 1 mole of oxygen mass, its mass number is equal to 16 grams. 1 mole of calcium atomic mass 40, so 40 grams. Similarly, 1 mole of water molecules mass, so molecular mass of water H2O 18 grams. Similarly, 1 mole of carbon dioxide, so that is 44 grams. Is this clear? So that is about the molecular mass and number of atoms. Okay. So once if you see the students page number in your material 60, okay, in your material if you see the page number 60, understanding of mole, one concept is given. See here. So one example is given about the understanding of mole. So in understanding of mole, what is given? See here, 1 mole of nitrogen gas. See here, 1 mole of nitrogen gas. So you know that 1 mole of nitrogen gas, okay, contains 6.023 into 10 to the power of 23 molecules, right? Now, if they ask you to weight, okay, so weight means what? Just you have to, if you want to weight now, so you are calculating weight. So nitrogen molecules, so 2 nitrogens are there. So each nitrogen atomic mass is 14. 14 2s are 28. So 1 mole of nitrogen gas weight is 28 grams. How many grams? 28 grams, right? And 1 mole of nitrogen contains how many molecules? So 1 mole of high nitrogen contains 1 mole. So that is contains 6.023 into 10 to the power of 23 nitrogen molecules, right? Now here it contains how many atoms? So each molecule contains 2 nitrogen atoms. So now just multiply with the 2. 2 into 6.023 into 10 to the power of 23. Okay, nitrogen atoms. Okay, so like this we can calculate the mass, numbers and everything. Now one more important thing. Here nitrogen is gas. Okay, if they ask you 1 mole of nitrogen gas consists of means what is the volume of 1 mole of nitrogen gas. So here we have seen the grams and we have seen the numbers, but we didn't see the volume, right? So for that first we see here. So 1 mole of Okay, so 1 mole, listen here, 1 mole of any gas, remember here, any gas at STP, standard temperature and pressure. STP means what? Standard temperature and pressure occupies 22.4 liters. How many liters? 22.4 liters. So here 1 mole of any gas. 1 mole of which gas? Any gas. 1 mole of any gas at STP occupies 22.4 liters. So, here 1 mole of nitrogen is 28 grams in weight. 1 mole of nitrogen gas means this many number in terms of number, and in terms of volume. So, at STP, standard temperature and pressure. So 1 mole of nitrogen gas contains 22.4 liters. How many liters? 22.4 liters. Okay. So 1 mole of nitrogen gas occupies 22.4 liters at STP. If I ask you 1 mole of, instead of nitrogen, 1 mole of oxygen occupies how much? Again the same. 1 mole of any gas at STP occupies 22.4 liters only. If I ask you 1 mole of hydrogen occupies how much, what's the volume? Okay, how much 1 mole of hydrogen occupies, what's the volume? Okay, at STP, again 22.4 liters, that is fixed. So, how the number is fixed? 1 mole is equal to 6.023 into 10 to the power of 20 fixed number. Similarly, for any gas at STP, the volume is fixed, that is 22.4 liters. That's what? 22.4 liters, but this is applicable only for the gas, and this is constant only at the standard temperature and pressure, particular temperature and pressure only. It's not for all temperatures and pressures. Right? Chalo. So with this, the main concept is done. Now let's say some important formulas here. For atoms, if you want to calculate the mole, so you have to divide the given weight by atomic weight. For molecule, so given weight by molecular weight. For number of atoms, atomic weight into Avogadro's number, that's 6.023 into 10 to the power of 23. Same this also. And number of moles of 1 gram. For example, 1 gram of any substance is given. How many number of molecules are present means what? 6.0 into 10 to the power of 23 by molecular weight. These are the important formula. These are given in material only in the page number 61. Okay. Now let us solve some questions here. Open the page number 62. Now see here. The amount of substance of a system which contains as many elementary entities as there are atoms of 0.012 kilogram of carbon. So see here, practice sheet 2 concept. Okay, so 2 practice sheet, page number 61. In this, see now concept based questions. 0.012 kilogram, 0.012 kilogram. So 0.012 kilogram means what? 1 kilogram is equal to 1000 grams, correct? So here, if you want to convert into grams, you have to multiply with 1000. When you multiply with 1000, this becomes 0.012 kgs. Okay, it becomes 12 grams. How many grams? 12 grams it becomes. Okay. So 12 grams is given. Now 12 grams of carbon, 12. So 12 grams of carbon consist of how many atoms? 6.023 into 10 to the power of 23. This is nothing but a 1 mole. So the option is fourth option. See here, 12 grams of carbon already we discussed in the first slide. See here, 12 grams of carbon contains 6.023. This is nothing but a Avogadro's number is nothing but a mole, right? This is so option is mole is the right answer. So the option is 4 for first question. For second question, you see the Avogadro's number is denoted by what? Na. Already I discussed you. Okay, Na. Next is the third question. Third question is 1 mole of any substance is equal to gram atom. In terms of atom, gram atom. 1 mole gram molecule. In terms of molecule, gram molecule. Avogadro's number, yes. So all of this. So all of the above. So the third question, the answer is fourth option. That is all of above. Fourth question. 1 weight of a mole of atoms of an element is called molecular weight? No, because they are given atoms. Gram atomic weight? Yes, atomic weight, gram atomic weight. So fourth one is 2. Fourth one is what? 2. Okay. Next, fifth one. Number of moles given weight by gram molecular weight? Yes. Given weight by gram atomic weight? Yes. See, already written the formulas here. See, given weight by atomic weight, given weight by molecular weight. So the option is fourth option here. Once again, the option is fourth option. All of this for fifth question, the option is 4. Okay. Now go to the sixth question. Number of atoms in 1 gram of element or this also given. This one, the number of atoms in 1 gram of substance, 6.023 into 10 to the power of 23 by atomic weight. Okay, so that is first option. So sixth one is what? First option. Seventh one, 1 mole of carbon dioxide molecules contains mole 6.023. So 6.023 oxygen atom, 6.23 carbon atom. So see, 1 mole of carbon dioxide, they said 1 mole of carbon dioxide. Okay, so 1 mole of carbon dioxide consists 6.023 into 10 to the power of 23 carbon dioxide molecules. But what they are asking here, okay, carbon. So 1 carbon is there. So 1 mole. So the option is this only. So the option is second option. 1 mole of carbon dioxide contains 6.023 into 10 to the power of 23 carbon atoms. If they ask you how many 1 mole of carbon dioxide consists how many oxygen atoms, then each molecule consists of 2. So you have to multiply this with the 2. So that many is the right answer. Okay. So here they asked about the carbon. So second option is the right answer. Now eighth one. Eighth one, you see this is little complicated. You try to understand here. The number of oxygen atoms present in 10.6 grams of sodium carbonate. Okay, the number of oxygen atoms present in 10.6 grams of sodium carbonate Na2CO3. So for this, first you need to find the moles. So mole is equal to given weight by molecular weight. This is the formula. Okay. Say this formula already we learnt in the solution chapter also. Mole calculation. So mole is equal to molecular weight of sodium carbonate is 106. You should know that already this will be calculated from the solution chapter onwards. Weight, no. So weight is given 10.6. So 10.6 by molecular weight is 106. So 10.61 are 10.6 tens are. Okay. So this becomes 1 by 10 is equal to 0.1 mole. Okay. So 10.6 grams of sodium carbonate contains 0.1 moles. Clear? Now they are asking how many oxygen atoms are present. So 1 mole of sodium carbonate contains 6.023 into 10 to the power of 23 molecules, right? But here how many moles are there? 0.1. So 0.1 mole contains 6.022 into 10 to the power of 22. Why? Here 1, here 0.1. So 1 to make 0.1, what we need to do? We have to divide with the 10. If you divide 10 to the power of 23 by 10, what will get? 10 to the power of 22. Okay. Now this is there. Now 1 molecule of sodium carbonate contains how many oxygens here? 3 oxygens. So asking to find the number of oxygen atoms. each molecule Na2CO3. So 3 oxygens. Now you multiply this number with 3. 3 into 6.022 into 10 to the power of 22. So 3 2s are 6, 3 2s are 6, 3 0 0, 3 6 are 18. 18.066 into 10 to the power of 22. Or if you change this point here, we can write 1.8 1.8066 into 10 to the power of 23. So the answer might be in this, anything will be there in your option. So check here, 1.806 into 10 to the power of 23. We got this answer only. Okay. So the answer is the first option. Did you understand how to do? So here first they are asking that to find the number of oxygen atoms present in 10.6 grams of sodium carbonate. So we have a formula that mole is equal to weight by molecular weight, given weight by molecular weight. Given weight is 10.6. Molecular weight of sodium carbonate is 106. Okay. If you divide, you will get 1 by 10. That's called 0.1 mole. We know that 1 mole is equal to 6.023 into 10 to the power of 23. And 0.1 mole means what? You have to divide with 10. So dividing this with 10, you will get is 10 to the power of 22. Right? But this each molecule consists of 3 oxygens. They are asking to find oxygen atoms. So 3 into this number. Okay, you will get this one, and this is a final answer. Clear? In this way, you have to calculate. Okay. Similarly, the mass of 1 mole of electrons is. The mass of 1 mole of electrons is. So what you have to do here? 1 mole of electron. Each electron mass is how much? Okay. The mass of each electron is how much? Okay. That into 6.023 into 10 to the power of 23. If you do, approximately you will get in grams. So that is 0.55 grams. Okay. So the option is the second option. Okay. Second option is the right answer. Clear? Then come to the 10th one. The number of atoms present in helium 100. Okay. So now, see here, 100 grams of helium is there. 100 grams of helium. Now they are asking how many? Number of atoms. So what you have to find? First you have to find the number of molecules, number of moles. Okay. Number of atoms of helium in 100 atomic weight. Yeah. So number of moles is equal to weight, given weight by atomic weight. Given weight is how much? 100 divided by helium atomic mass is what? 4. So that is 25. What did you get? 25. So here that is actually 25 moles. Okay, 25 moles. So they should ask that the number of moles is the right answer. They should ask how many moles of helium is present in 100 U. Okay. So here it is given wrong, question is wrong, but answer is 25. So the number of moles, atoms you cut it and write the moles. Chalo, okay students, so with this we stop for today, and remaining you try. So these are all questions based on the formulas given in your material, page number 61 and 62. So in the page number 62, some important relations are there. That formulas you have to learn perfectly so that you can solve the remaining problems. Okay. So with this we complete, we stop the class. Okay. Try the problems. Don't just listen and leave. So practice almost all the numericals. Okay. Bye. Take care.